Okay, so we're going to start today on chapter 7.3, okay, and we're going to be talking about similarity and transformations. So we've been talking about transformations a lot, okay. Does anyone remember what are the different types of transformations? There's 4 different kinds of transformations. What's any of them? Rotation, okay. Reflection. Translation. Now, if something is going to be congruent, okay, congruent means the exact same shape and size. The only way that we can move something that's congruent is by these ways, okay? So you can only, so if something is exactly the same, it could have been moved or transformed, by rotation, reflection, or translation. Today, we're going to add in, what's the last one? Dilation, okay? So we're going to be talking about similarity. This includes dilation. Okay, so similarity doesn't mean the exact same shape and size. It means the exact same shape, but not the exact same size. Okay, so today we're going to be working on figuring out if things are similar, if they're the exact same shape, but not the same size. Okay, and the only way that they could be not the same size is by using a dilation. Okay, so first one we're going to look at, it's going to ask you determine, or for example number 1, determine if the two figures are similar by using transformations. Okay, determine if the two things, or if the two are similar by using transformations. Excuse me. So, first one we're going to look at is, sorry, I just lost my place. Okay, so if you have some grids, you're going to want to use a grid. Okay, if you don't have any grids, then you can get a piece of paper, you can just write it on there. Okay, but I'm going to use a grid. Once I got my scissors. Okay, all of your examples will already be on grids, okay, so you won't have to draw any of them. Okay, but if you have any grids, you're probably going to want one. And if you need one, you can tape it on or just draw it. Okay, or you can just believe my example and you can look at it. Okay, so if I have 2 triangles, okay, the first one is, and you don't have to worry about the different coordinates, okay? We're really just going to be looking at just the first quadrant. Does anyone know what a quadrant is?
It's one of the 4 thingamajigers.
One of the 4 thingamajigers, yes, okay. We're just going to be looking at the ones that are positive. Okay, that's basically what I'm getting at here. Okay, so if I graph, let's see. Let's go. One of your sides is 1, 2, 3, 4. So 1, 2, 3, 1, 2, 3, 4. Right, and then another one is going to be, let's say, from here. So, what we're going to look at here is, first off, these would be labeled, okay? So, this is more of going to be, like, you guys don't have to draw this today. I just want you to really pay attention to what I'm doing, okay? And G, H, and I, okay? Because it might be kind of hard for you to draw that. So, what we're really looking at today is we're going to look at the sides, okay? And figure out which ones would kind of match together, okay? So, which ones would you say are kind of congruent to one another? Which sides would you, if I was going to write a similarity statement, And I asked you to write a similarity statement. How would you do that, Chantal? Since you're not in the right seat, you might as well be helpful.
What did you say?
Give me which sides are similar.
D and I.
Okay, sides have two letters. So, like, this is one side, so DE, okay, is similar or congruent to which other side in this triangle? The one on the left, on the bottom, or on the hypotenuse? The bottom one?
Yeah.
So you're saying this side is similar to this side? No. Then which one? GH, so the one on the sides, you're saying that the sides are similar to each other, right? Okay. The way that we figure that out is figuring out how long each one is, okay? So we're going to set up a ratio. So you're going to say DE over GH, okay, is equal to what? How long is DE? If you count those. It should be 1, 2, 3, 4. Over GH is how long? It's supposed to be 8. Okay? If you reduce that, what does that equal to? 1 over 2. So we decided that the ratio to get from here to here, for every one of these, there's 2 on this side. Now we need to set up another ratio and figure out if they are the exact same. So which other 2 sides are similar to each other? Which other 2 sides do you think are similar to each other? The bottom ones, right? Okay, so the bottom parts. So DF is similar to which other one? DF is similar to which one? GI. Now we're going to set up the exact same ratio, and we want to see if they're the same. So we're going to do the little one over the big one. Okay, you could do it either way around, doesn't really matter. So DF over GI. How long is DF? Go ahead. How long is DF? 2. Over, how long is GI? 4. Does that reduce to the exact same thing? 1 over 2. Since these are the same, okay, since the ratio of the sides are exactly the same, then you can say, yes, the triangles are similar. So determine if the 2 figures are similar by using transformations, Yes, these are similar triangles. Okay, and the way we check it is by checking what's called their ratios. Okay, so yes, they are similar. Okay? Questions on how I did that? So I know that's a little confusing, okay, but once we do a couple of them, hopefully it'll become a lot easier. Okay, questions on how I did that? No, you think you're okay? Okay, let's try another one, number 2. There should definitely be a lot of writing on there, Blaze. That's not your name. Blaze, all that should be written down. Dude. Okay, for number 2, again, I want to determine if the 2 rectangles are similar using transformations. Determine if the 2 rectangles are similar using transformations. Great. Thank you. No, just go. Okay, so we're going to make some rectangles, okay, and this time I'm not going to put them on a grid. Okay, this time I'm not going to worry about putting them on a grid, okay, but I will count them for you, okay? So I will tell you how long they are. Now, keep in mind that my drawing is probably not very good. In fact, it's not very good. I'm telling you already. Okay? So you can't decide if those are exactly the same based on my drawing because, you know, it's not very good. So I'm going to label these T, U, V, and W, X, Y, and Z. So we want to figure out, are these two rectangles similar using transformations? Okay, and I'm going to tell you that the side TU is 3, UV is 5, WX is 4, and XY is 7. So if you had these on a grid, you would just count them, okay? And we want to figure out, are these similar? So first off, are they even like pointed in the right direction? No, one is sideways and one is kind of up and down, okay? So which ones do you think we should compare to each other? Any ideas? Which ones do you think should be compared to each other? Court, which ones do you think?
X and Y to WV.
So you think XY should be compared to which one? WV, the side one? Okay. Those would be side to side. So if you drew this, okay, we have one rectangle that's basically 3 by 5. Would you agree with that?
Yes.
And another rectangle that has the same corner, but it is 4 by 7. Do we agree on that one? Okay. If we were going to flip this sideways, okay, if it was flipped sideways, it would be kind of like this, right? And the 3 would be on the bottom, the 5 would be on the side. Does that make sense? So what you always want to do is you want to compare like the skinny parts together and then the longer parts together. So is 3 over 4 equivalent to 5 over 7? Do those equal each other? Are those correct reduced fractions? So do you think that these rectangles are similar? No. Okay, these are not similar. Okay, so basically a lot of what you're going to be doing today, and we'll do a bunch of them together in class, okay? A lot of what you're going to be doing is just comparing measurements to figure out, are they similar to each other? Okay, we're going to do one more, and then I'm going to help you guys with your homework today because this is a little confusing. Well, it's more than a little confusing. Okay, let's look at, for number 3, you're going to have to do a little bit of writing. Okay, if I tell you a baker, like a cake baker, is reducing an 8 by 10 inch photo. She's going to reduce an 8 by 10 inch photo to place the image on a cake. To place the image on a cake. Okay. He reduces it by a scale factor of 0.8. Then decides it's still too big. And reduces by a scale factor of 0.9. Okay, I want to know, find the dimensions of the final image. Okay, I want you to find the dimensions of the final image. Sorry, I'll give you guys just a minute to write that down. So basically, we have this big picture, okay? And we said it's 8 by 10, okay? 8 inches by 10 inches. And we want to fit it on a cake, okay? Well, the cake is like kind of tiny, okay? You don't want to just take this whole picture and put it on there because then like the edges would be off, okay? That doesn't make any sense. So we're going to have to reduce it, okay? So does anyone remember, what does it mean if you have a scale factor? Scale factor basically tells you what?
That's how much you want.
That's what you multiply by. Exactly. So the first time he multiplied both of the sides by 0.8. Okay? Now, I'll even let you use calculators on this. Okay? If we multiply both of these by 0.8, actually you don't need a calculator for this first part. Okay? If we multiply by 0.8, what is the first one that he reduces it to be? How big would it be? If I multiply both of those by 0.8. Multiply both of those by 0.8 and tell me what do we get? If you multiply by 0.8, 8 times 0.8 gives you what? 6.4.
Oh.
Okay. 1 decimal place. And then what's 10 times 0.8? 8.0. But then he decides, it's still too big. Okay? So I'm going to multiply again by 0.9. Now you have to multiply. So do 8 times 0.9, and what do we get? 7.2.
Yeah.
And 6.4 times 0.9. Work it out on your paper if you need to. .4 times 0.9. Not exactly. Okay, 6.4, so it's not going to get bigger, it's going to get smaller. 6.4 times 0.9. You guys can do the multiplication. Do I need to randomly call on someone? 6.4 times 0.9. Mark. Okay, keep doing it. Do it. Yeah. 5 point what? You guys are having some issues with this multiplication. 6.4 times 0.9. Okay. Rihanna. Okay, Rihanna, go to Sierra. Okay, multiply through and, I'm sorry, what did we get? 5.76. Okay. 2 decimal places because there was 2 in your answer, so 5.76 inches. Okay, so when it asks what's the final image, these are your dimensions. Now, is this a similar figure? Is this similar to the original one?
Yeah.
How do you know? Because you multiplied all the parts by the exact same thing. Okay, so yes, this is similar to the original. Yes, this is similar to the original. Okay, what we're going to work on today is your homework is going to be on page 541, and you're doing numbers 1 through 5 and 12 to 14. Okay, 1 through 5 and 12 through 14. You guys are going to have a test on this pretty soon. Okay, so make sure that you are understanding this. Okay, you have plenty of time to be working right now. So I